on part 3 of the 8-8 worksheet, and the rules for adding are a lot looser than the rules for adding and subtracting. Adding and subtracting, we had to make sure that we got common denominators before we could. You could not simply add and add, right? That's incorrect for adding. True? A third of something plus a fourth makes 2/7. That doesn't even make sense. Think about the fraction of a candy bar. If you take a third of it and add a fourth of it, you'd have a lot more than 2/7 of it, right? So that doesn't make sense. For adding and subtracting, you need to try to get a common denominator. For multiplying, you do not. For multiplying, it's the easiest of all 4 operations. With fractions, you just multiply the top, multiply the bottom. For number 2, 2 times 4, 8, 5 times 5, and are pretty simple. Don't get a common denominator. Now, some students will still try to get a common denominator, and that's fine, but it's silly and it's a waste of time. So don't bother getting a common denominator when you're multiplying. When you're dividing, there are 2 different ways of doing it. You can either do this, never change the first fraction, change the second fraction to its reciprocal. What do you get? 36 over x times x is x squared. Okay, you do multiply on the bottom as well. So that's where you multiply by the reciprocal. That's one way of doing it. Another way is students like the concept of cross multiplying. So when you're dividing, what you end up doing is the 3 times 15 on top, 45, and then the 5 times the 9 on the bottom, which is also 45, and you get 1 when you reduce. Now that leads me to this whole concept of reducing and canceling to make your life a little bit easier. You see, the alternative to cross multiplying here would have been 3 over 5 times, what's the reciprocal of 9/15? 15/9. You still get 45 over 45, but one thing that you can do with multiplying and dividing, let's stick with multiplying, is look for any common terms that can cancel. For example, can 5 cancel with 15? Yeah, 5 goes into that 15 3 times and becomes a 1 on the bottom. Similarly, can the 3 and the 9 cancel? Yeah, 3 goes into 3 once, and 3 goes into 9 3 times. So we have 1 times 3 over 1 times 3. The 3 over 3 cancels as well, and you just have 1. So that concept of canceling will come in handy when you go to do something like number 5. We're multiplying, so is there any need for a common denominator? No. We're multiplying, so do we need to multiply by the reciprocal? No, that's for dividing. So we're ready to start looking for things to cancel and then multiply some stuff. Is there anything on the top that matches something anywhere on the bottom? Yeah, it doesn't have to be within the same fraction. It can be in the other one. The 8 and the 8 cancel. They kind of just get out of our way. Furthermore, the x plus 1, if you want to let me finish. Furthermore, the x plus 1 and the x plus 1, they cancel as well. Now, I want you to note that what you can't do, let's pretend for a minute that this x plus 1 wasn't there. You cannot cancel this x with this x. That's illegal because the x that's on the top is being added to 1. So it's not a common factor that you can cancel. But if this entire thing, x plus 1, matches an entire factor on the bottom, x plus 1, then yes, they both completely cancel, and you're left with 2 over 7x, and that's it. Nothing else can cancel or simplify. So at this time, I'm going to set you loose on finishing 6, 7, and 8, and see how you do. 4A, 4B, 4C is like an extension problem if you like the extra challenge. Try it.